So hello guys, my assigned topic is all about the moment area method, and in this video I will give the definition and solve a problem involving this type of method. So first, let's hear its definition and uses. The moment area method provides a way to find slopes and deflections without having to go through a full process of integration. There are two moment area methods, one that relates to the slope of the beam and one that relates to the deflections. In this method, the area of the bending moment diagrams is also utilized for computing the slope and or deflections at particular points along the axis of the beam or frame. Then we could now solve the problems given. Here is the question. For the prismatic beam unloading shown, determine the slope at end A and the deflection at the center C of the beam. The key points to remember is M is the bending moment, EI will be the flexural rigidity of materials, P is the concentrated load, L span length of beam, the theta is the slope, T will be the displacement, and Y or gamma is the deflection. So this is our free body diagram that shows the area moment diagram, which could be helpful in solving the beam deflection and finding its slope. And for our solution, we should place the reference tangent at C. Therefore, our slope at C is 0 and the deflection at C is equal to the displacement between points A and C. So we have P is equals to reaction A plus B as the reaction at equilibrium, and our moment about A is 0. Then to solve the reaction at B, we have to solve this equation. 1 half PL minus reaction at B times L equals 0. Then our RB will be equate and will be equal to 1 half P. And for the reaction A is also a 1 half P by solving that equation. By using the bending moment at C, 1/4 PL, we could then solve our area, such as using the area of the triangle. We have 1 half base height, so our area will be 1 half times 1/4 PL over EI, this is our base, and L over 2, this is our height. So therefore our area is 1 over 16 PL squared over EI. Then let's proceed on finding the slope at A. So our solution will be theta A is equals to theta C minus theta between point C and A. So our theta C is 0 minus the area that we get, which is 1 over 16 PL squared over AI. And for the final answer, we have theta A is equal to the negative 1 over 16 PL squared over AI. In finding the deflection at C, we have the deflection at C is equals to the negative displacement from point A between C, and to find this is we should use the figure from our free body diagram to find the centroid, which is L over 3, and our area, which is the one that we solved earlier. It will be negative times the area, which is negative 1 over 16 PL squared over EI, times the centroid, which is L over 3. So our answer at deflection at C will be 1 over 48 PL cube over EI. And for our conclusion, Therefore, the slope at the end of A is negative 1 over 16 PL squared over EI, and the deflection at the center C of the beam will be 1 over 48 PL cubed over EI.